Alright, so here we are in Chapter 3, Section 2, problem number 3. So we have a sample space for 3 tosses of a coin, and they're showing the H's and T's being for heads and tails, so the small h, small t represent that. First one, H, 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 so 3 heads. Then heads, heads, tails, heads, etc. So to find events, capital H, at least one head is observed. So several of those, and then M, more heads than tails are observed. Alright, so for A, we're going to list the outcomes that comprise H and M. So, alright, so we have A, computer to draw. Hello, here we go. Alright, A. There we got it. Okay, H equals, so H again is at least one head, so for at least one head we have H, 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 T, H, T, H. We could be looking at these and do it this way, or we could say, oh look, everything will have a head in it except the one where we have all tails. So another way to look at it, but I'm getting these all written out here. H. 1, 2, 3, 4, 5, 6, 7. Okay, there are 8. One of them has all tails, so that one wouldn't be there, so H has 7. Okay, then M is going to equal more heads than tails. So we have 3 more heads than tails. Means I have at least 2 heads. So anything with at least 2 heads is more heads than tails. Okay, heads and tails, right? So that's H, 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 T, H, T, H, T, H, H, and 1, 2, 3, 4. Okay, those 4 for M. Okay, now we go to B. List the outcomes. Okay, we're going to have H intersect M. So when we have intersect is what's in both. So that what's in common between the 2 sets. If we look at those 2 sets, we have H, 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 T, H, T, H, T, H, H. So at least one head and more heads than tails. So everything that's in M is going to be in H. Okay. So union, H union M. It's like home. I know. We'll keep going from there. So if we're going to put them together, that's the combination of both. And the combination of both, since everything in M is in H, H is actually the union of them both. So it's got it. H itself. Yeah, so we can write those all out. I'm just going to put H to be the union of H there with that. Okay, C, assuming all outcomes are equally like, oh, you know what I did not do? I did not do H, C, so the complement of H. So the complement of H is everything that's part of the sample space that's not in H. So when we look at that, H had everything in it but TTT. So that TTT is the one element that's the complement, because that's what isn't part of H. So TTT. H is 7, right? 1, 2, 3, 4, 5, 6, 7. That would be the 8th one. That's the one that's not in there, so that's the complement. Now we can go to C. So we're looking here at probabilities. So we're trying to find the probability that the event of H intersect M, so that's the outcome we're going to get. Also the probability of H union M, and the probability of H complement. Okay, so here it says the probability of all, or assuming that the outcomes are equally likely. So we have 8 outcomes, so each outcome is 1/8. So the likelihood of any one of those outcomes is 1/8. So H intersect M and H intersect M, we have 1, 2, 3, 4. 4 outcomes that are in that, so 4 out of the 8 are possible. So each of those is an outcome, a likelihood of 1/8. So we have 1/8 plus 1/8 plus 1/8 plus 1/8. Did I say that 4 times? Yeah, like 4 1/8s. So this would be 4/8 or 0.5. Alright, so H intersect M, H union M, that was essentially H, the probability of H occurring. So we have 7 of the 8 possible outcomes. So that would be 7/8 in terms of the outcome there, or 0.875. And then the probability of H complement, we see them back there in B, the complement of H is only one item. So we're adding up all the possible outcomes there. There's just one, so that's 1/8. Or 0.125. Alright, so we're going to go to D. In D, determine whether or not H complement and M are mutually exclusive. So mutually exclusive, meaning there are no elements that are the same in either of the potential events. So the events are exclusive from each other. Event M is, you can see that up at A, the HHH, HHT, HTH, THH, and then the complement of H is TTT. So TTT is not part of M, so it is not in common, so they are mutually exclusive. So yes, HC and M are mutually exclusive. There's example 3.